Unit 3, Congruence in Triangles. This lesson is about coordinate proofs. Your objectives for this lesson, only one, is to use coordinates to prove simple geometric theorems algebraically. Okay, so when we're talking about coordinate proofs, I've mentioned this in class already. We're talking about proofs that are written using figures in the coordinate plane. So you are combining proofs and graphing. For this first example, you are going to need the distance formula. You'll need these for several of the coordinate proofs, including one on your test. So d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So square root. Okay. And also remember, an isosceles triangle has at least two congruent sides. Okay. Example 1 is the triangle with vertices A 4, 2, B negative 1, 4, excuse me, and C 2, negative 3, an isosceles triangle. In other words, does it have at least two congruent sides? So I'm going to start this off by plotting my points. So I have A at 4, 2, B at negative 1, 4, and C at 2, negative 3. So I have this triangle here. I'm going to connect the dots. Okay. And now what I really want to do is find the length of each side. So I'm going to plug in the coordinates into the distance formula for each of these. So I'm going to find AB first. And if I label these points, I have 4, 2, negative 1, 4. We make this x1, y1, x2, y2. So my distance is going to be negative 1 minus 4 squared plus 4 minus 2 squared, square root the whole thing. And I get negative 5 in parentheses squared plus parentheses 2 squared, square rooting this. So I have 25 plus 4 under my radical, which means I have the square root of 29. And I'm just going to leave it like this. Okay, so this is square root 29. Next, I'm going to find BC. So let me label C. This was at 2, negative 3. Yep. And I'm going to make this my x1, y1. Okay. So BC. D is negative 1 minus 2 squared plus 4 minus negative 3 or plus 3 squared, square root the whole thing. So I get the square root of negative 3 squared plus 7 squared. This is the square root of 9 plus 49. Okay. Which gives me the square root of 58. So this is the square root of 58. Oh, not 8, 58. Okay. And last, I want to find AC. So let me move these. Make this x2, y2. Okay. So for AC, D equals the square root of 4 minus 2 squared plus 2 minus negative 3, or plus 3 squared. 4 minus 2 is 2 squared plus, this is the 5 squared. So I have the square root of 4 plus 25. Okay. And this is the square root of 29. Okay. So let's take a look. Oh, looky here. We have square root 29 and square root 29. Since those are the same, yes, this is an isosceles triangle. So yes, because two sides are square root 29 units long. So that's our answer. For our next example, we're going to use the midpoint formula. So remember the midpoint formula, m equals, we're going to add up our x's, divide by 2, and add up our y's, and divide by 2. So this is my midpoint, x comma y. Okay, example 2. Use the coordinates shown below to prove that in a right triangle, the midpoint of the hypotenuse is equidistant from all three vertices. So the first thing I'm going to do is find the midpoint. Then I'm going to do the distance formula between B and M, A and M, and C and M. Okay, so my midpoint, M, is going to be, it's the midpoint of B and C. You can see from my diagram. So I'm going to add up my x's, so 0 plus 2a, divide by 2, comma, add up my y's, 0 plus 2c, and divide by 2. So I get 2a over 2, comma, 2c over 2, which gives me a comma c. So this is my midpoint, a comma c. And my next step is to do the distance formula for all of these points. So let me start with MB, and I'll call this x2, y2, x1, y1. So MB is going to be the square root of a minus 0 squared plus c minus 0 squared. This is a squared plus c squared under my radical. And I can't really do anything with that, so I'm just going to leave it like this. This is MB. Let's find MC next. Do this one in blue. So MC, I'm going to change my C coordinates to x2, y2, and my M coordinates to x1, y1. So I have 2a minus a squared plus 2c minus c squared, square root that whole thing. 2a minus 1a is a squared plus 2c minus 1c is c, and it's squared. So I have the square root of a plus c, which you can see those are the same. That's good. We want all three of these segments to be the same. The last one I'm going to do here, I'll move x2, y2 down to a, so 2a comma 0. Okay, so now I'm finding MA, and I'll do this in green. Okay, so x2 is 2a minus x1 is a squared plus y2 is 0 minus y1 is c. So 0 minus c squared. Okay, square root. So again, 2a minus 1a is a, and we're squaring that. So a squared. And then 0 minus c is negative c. When we square that, though, we get a plus c squared. So again, I have the square root of a squared plus c squared. So since all three vertices are the square root of a squared plus c squared units from M, okay, we can say the midpoint of the hypotenuse is equidistant, or the same distance, equidistant, from all three vertices of the triangle. Example 3. How do you prove or disprove that the triangle with vertices A, -2, -1, B, -6, -1, and C, -4, 5 is an isosceles triangle? Well, from what we've done so far, I can tell you that I'm going to have to do the distance formula 3 times, and I want to see which, if any, side lengths are the same length. So let's do that. So copy this. Okay, let's find AB first. So AB is going to be the square root of -6 minus -2, or plus 2, squared, plus -1 minus -1, or plus 1, squared. Okay. This is -4 squared plus 0 squared. So this is the square root of 16, which is 4. Okay. BC, we're going to say the square root of -4 minus -6, or plus 6, plus 5 minus -1 plus 1 squared, square root the whole thing. Okay, maybe we'll get lucky and these two will be the same, we can stop. So -4 plus 6 is 2 squared, plus this is 6 squared. So I have the square root of 4 plus 36, just the square root of 40, not what I was hoping for. So let's find AC. Okay, AC equals, say -4 minus -2 is plus 2 squared, plus 5 minus -1 plus 1 squared, square root. Okay, so this is -2 squared plus 6 squared. Okay, which gives me -2 squared is 4 plus 6 squared is 36. Oh goodness, and we have the square root of 40. That's beautiful. So these two match. Okay, so BC and AC are the same. Now let's go back here. There are some answer choices that I hid from you. So how do you prove or disprove that it's an isosceles triangle? Are we going to disprove it? No, don't disprove it. We just figured out that two of the sides have the same length, so it's not A. Do we prove it by showing AB equals BC? Well, which two equaled? AC equaled BC, so AC and BC is what we want. That's not it. Nope. Okay. AB equals AC? Nope, still not it. Let's see for D. BC and AC, yes, this is what we want. So we use the distance formula to show BC equals AC. Okay, and that, well, this is very similar to a test question that you're going to have. Remember, your test is on Thursday. But other than that, that is it for this lesson.